This video, I'm going to help walk you through some of the homework problems from My Math Lab 6.5. That's homework number 5. Find that our My Math Lab curriculum doesn't line up precisely to our old textbook. So this homework number 5, if you're doing the My Math Lab homework, is there on My Math Lab, but it's out of the textbook. It's going to be some problems from 4.4 and some problems from 4.5. So here's a video that'll walk you through some of those problems. I'm going to start with the first homework problem. So on My Math Lab, that's homework problem number 1. In the textbook, it's 4.4, number 23. And here we have an example of an indefinite integral. And the directions ask us to evaluate the integral. Notice that I called this an indefinite integral because we don't have any integrating from A to B. It's just integral. And so our final answer is going to have a constant of integration, a plus C at the end. But this matches up very homework problems that you find in 4.4, numbers 5 to 16, where we have some indefinite integrals. Here's how we'd approach this. To start with, what we're going to do every time can be easily simplified, as this one can. We're going to simplify it. We can distribute the v squared plus 2 times v squared plus 2 to get v to the 4th plus 4v squared plus 4, and then distribute a v, so we get the integral of v to the 5th plus 4v cubed dv. And this is our indefinite integral, and we'll just use the power rule to integrate. And here's a good way to remember this if you're still working on keeping a difference between doing a derivative in which the exponent falls or decreases by 1 and doing an integral where it increases. Think of it as a stair step. We started with derivatives and then we went up to integration, to integrals. So the exponent, when we integrate, is going to go up, just like integrating was a step. So when we integrate v to the 5th, we get v to the 6th, and then divide by the exponent 6. 4v to the 3 plus 1, or 4 over 4, plus 4v to the over 1 plus 1, plus our constant of integration. We simplify this, so we have v to the 6 over 6. The 4's reduce, so we have v to the 4. 4 divided by 2 is 2, so 2v squared plus c. And that's really all there is to it with evaluating an indefinite integral. This next example is a little bit more tricky because it's and this is similar to the homework problem. Let me see, I don't see which homework problem it is precisely, but this is a really important integral to be able to do. So I wanted to be sure to do an example. From 0 to 2, the absolute value of 2x minus 1. What we have to break this up. Oh, and I see where it is. It's in the book. It's similar to homework problem number 39 with a definite integral. So this is similar to the 4.4 problem 39. Not quite the same, but similar. And so the first step is we're going to have to break this absolute value into two pieces because 2x minus 1 absolute value is a piecewise division. So just a review of the algebra. If I take the 2x minus 1 and set it equal to 0, 1/2, that tells me that this absolute value of 2x minus 1 broken into a piecewise defined function. We have the description of f of x when x is less than 1/2, and the description of f of x when x is greater than 1 is non-negative. That's the case when x is greater than 1/2, 1. When 2x minus 1 is negative, we get the opposite of 2x minus 1. Or in other words, when x is less than 1/2, this 2x minus 1 is negative, so the absolute value is going to be the opposite of 2x minus 1. The opposite of 2x minus 1 gives us negative 2x plus 1. So with an absolute value integral, this is the first step to function into a piecewise defined function. Notice that when I integrate from 0 to 2, you could see this on a number line. If I'm integrating from x equals 0 to x equals 2, I could break it up from 0 to 1/2, 2, and add those two integrals. So that's what I've done. And notice came from defining the function as a piecewise defined function, or in other words, it came from solving for x and seeing when this is positive to negative. When I'm going to integrate from 0 to 1/2 and then add that to the integration from 1/2 to 2. Now when x is going from 0 to 1/2, the absolute value of 2x minus 1 is the opposite of 2x plus 1. And when I integrate from 1/2 to 2, the absolute value is 2x minus 1. And from there, it's just like the other problems we did, doubles into a two-part problem. So we have the integration of negative 2x plus 1. So that's negative 2x to the 1 plus 1 over 2, plus 1 times x to the 1 over 1. And then we're going to add that to 2x squared over 2 minus x over 1. And this first one, we're integrating from x equals 0 to x equals 1/2. The second, from x equals 1/2 to x equals 2. This is a really important example. Make sure you understand why we've broken it into 1/2, to 1/2 and 1/2 to 2. Again, it came from setting the part that's inside the absolute value to 0 and solving. Then we broke the interval up and redefined the function in two pieces. From here, we just integrate, or I'm sorry, we already did the integration. So from here, we just substitute our x equals 1/2, x equals 0, x equals 2, x equals 1/2, and complete the to those. And then we've got to add our two problems together. If you go back and do that arithmetic, you should get that the final value comes to 5/2. Let's look at one more example type. And this one goes back to an indefinite integral. If you need more time with number 2, feel free to pause the video and then resume after you feel like you are caught up with it. Number 3. This is similar to some of the other homework problems you'll see. And this number 3, what we're going to do first is simplify rational exponents. We're just looking at how can I write this as something that's just a, and you can see that I could rewrite this cube root of x as x to the 1/3. Square root of x I can rewrite as x to the 1/2. So when I simplify this, I get x squared over x to the 1/3. So that's just x to the 2 minus 1/3, or x to the 1/2 minus 1/3, which is x to the 1. And then from here, I'm going to integrate x to the 5/3 by adding 1 and dividing it by that exponent, adding 1 and dividing it by the exponent. So you could finish this example in the same way. Find these examples helpful. I'm going to stop the video here, and then I'll pick up with additional examples using substitution from section 4.5 in the old book with the next video.